Hello and welcome. This is going to be our homework help video for the homework titled Systems by Substitution and Elimination. We'll skip the first two problems since that's just review from the last homework. Go right down to number 3, solving by substitution. What I need to recognize is that this first equation is already set equal to y. So this is already ready to go for substitution. The fact that the second equation is also set equal to y is just a little bit of a bonus. All we need is one equation set equal to y to be able to do the substitution. So I can use this expression for y to replace y in the second equation. Effectively, I'm just setting the two right-hand sides of these two equations equal to one another. So if this y gets replaced with this, my new equation will look like 2x minus 17 equals 3x minus 24. Now it's just a matter of combining our like terms. Maybe I'll move the 2x over. Negative 17 equals x minus 24. Add the 24 to both sides. And we get, I'll write it up over here, x equals 7. All right. Now that we've solved for x, we can plug that back into one of our original equations and solve for y. I'll just plug it into the top one to get y equals 2 times 7 minus 17, y equals 14 minus 17, y equals negative 3. How do we double check this, you might ask? We're going to take the values for x and y. If we plugged x into the top equation to solve for y, we'll plug them both into the second equation to make sure it balances. Negative 3 equals 3 times 7 minus 24. Negative 3 equals 21 minus 24. Negative 3 equals negative 3. It checks out. Now you might choose to leave your answers like this, and if it doesn't tell you otherwise, then that's fine. But if it asks for an ordered pair, give your answer as an ordered pair. Parentheses 7 comma negative 3. Another way to give our answer there. All right, let's see. In problem number 7, I think that'd be a good one to do. Yeah, problem number 7. None of the variables have been isolated yet, so we need to do the work of isolating one of the variables. I'll do it with the second equation because that y looks pretty easy to isolate. I'm going to take 7x away from both sides, leaving me with y equals negative 7x plus 6. Go ahead, now that I've got something that's equal to y, I can replace the y in the first equation with that expression to get 6x minus the quantity, negative 7x plus 6, equals 20. Parentheses, very helpful here to avoid making a mistake with the negatives, because now I can clearly see that I need to distribute this negative before I go any further. This becomes 6x plus 7x minus 6 equals 20. 13x minus 6 equals 20. Add 6 to both sides. 13x equals 26. Divide both sides by 13. We get x equals 2. It's half of our answer, but we're not done yet. Let's plug that into our, I think actually a really good place to plug it in is this manipulated form here. It more directly solves for y. That's going to get us y equals negative 7. Or 2. Negative 7 times 2 plus 6, y equals negative 14 plus 6, y equals negative 8. Double check with our second equation. Let's just do it out loud. 7 times 2, that's 14, minus plus a negative 8, or minus 8 is 6. 14 minus 8 is 6. That is correct. 4 is an ordered pair. 2 comma negative 8. Let's take a look at some elimination type problems. Starting with number 8. Number 8 is set up for elimination nicely because we already have a 0 pair. We can see a negative 4x and a positive 4x. So when I add these two equations together, adding the left side of the equal sign to the left side of the equal sign, right to the right, like terms are already lined up. These will eliminate. That's why this is called elimination. Now, negative 10y plus a negative 7y, that's going to be a negative 17y. Negative 12 plus negative 22 becomes a negative 34. Divide by negative 17, divide by negative 17. y equals positive 2. It's easy as that. Let's plug that into either equation to solve for x. I'll choose that second one. It looks maybe slightly easier. Both pretty similar, actually. 4x minus 7 times 2 now equals negative 22. 4x minus 14 equals negative 22. 4x equals a negative 8, I believe. And divide by 4, x equals negative 2. Check that with our other equation. 8 minus 20 equals negative 12. Yep. Works out. All right, let's look for one where we don't have a zero pair already. Like in number 11. This might look like a zero pair, but this is actually an identical pair. What I want to do is multiply one of my equations by a negative 1 so that I'll get a zero pair. So I'll just copy that first equation, 2x minus 6y equals negative 22. But for the second equation, I'm going to multiply it by a negative 1. So it's times negative 1. It's going to flip the sign of everything, negative 5x plus 6y equals a positive 10. And now this is a zero pair. These will add to be 0. Let's add them together, get negative 3x. These cancel, equals negative 12 divided by negative 3 divided by negative 3. X equals 4. Let's plug that into either equation. 5 times 4 minus 6y equals negative 10. 20 minus 6y equals negative 10. Negative 6y equals negative 30. Y equals 5. Not showing all my steps there. That's because we've done this several times already. And we could say it is an ordered pair. Double check with the other equation. 8 minus 30 equals negative 22. Yep, it checks out. You might be saying, I've got a shorter way to do this. I could have just subtracted the second equation from the first equation in the very first step. Yes, that will work because negative 6 minus a negative 6 does go back to 0. Let's look at one like number 14, where a zero pair is somewhat difficult to get. In this one, we can get a zero pair. Look for ways to simplify first. Like I could simplify this top equation by dividing everything by 3, and I'll get 2x plus 3y equals negative 9. And then I could multiply that by 2, so that the 2x and the negative 4x will form a zero pair. So now I've got 4x plus 6y equals negative 18. Copy down that one here, the bottom equation, negative 4x minus 7y equals 21. Add them together. These cancel out. These become a negative y. These become a negative, positive 3. Divide both sides by negative 1. Y equals negative 3. Let's plug that in to, I guess this looks like the most simple equation. So 2x plus 3 times a negative 3 equals negative 9. 2x minus 9 equals negative 9. 2x equals 0. X equals 0. Let's check that with maybe this one here. 0. That becomes a 21. 21 equals 21. And we can state our answer as an ordered pair if we want. There we go. All right, that's that for this homework. Hopefully that helped you get started.